Talk! Not Harinders. Listen to Harinder. Come on, go. I don't care. All right, 37. Who's 37? Ahmed, talk.
Oh,
Good job. So, anytime I differentiate a y, I put in y. Now, what's going on here with these first two terms? Product rule. So, when you see x squared times y squared, don't forget to do your product rule. Anytime you have an x and a y like attached to each other, you're going to have to do product rule with that. So, this is product rule here, derivative of the second times the first, plus original first times the derivative of the second. And I really like how you kind of took the two coefficient in the middle of these terms and put them in the front of that term. It's not necessary, but it looks a lot nicer. And that way you don't accidentally turn a coefficient into an exponent. So what do you do after you do your product rule here and differentiate the other terms? That's great. Some of you might have reduced this and said, hey, all these coefficients have a multiple factor of 2. So if you had 9 minus 1xy squared over 1x squared y minus 4y, that's also good. Then what? Negative 4 for all your x's, 2 for all your y's, and just magically, boom, 3 over 6. Okay. Calculate for that. Ooh, just use your own calculator because that's what you have to use on a test. You can't use math. Hold on, let me get Mathway up here on my laptop. It's not happening. So if you're gonna use your calculator, please, at least, but not Mathway. How would you type this in with a calculator? Guess how you would start? Parentheses. You got to put the entire numerator in parentheses. Then, no. 18. 18 minus 2 times x is negative 4 in parentheses times 2 root 3. Now your calculator might be old and force you to do parentheses around the stuff inside the square root. If it does, okay. But you close that, you square just the y, and then you put parentheses after the squared to close off the numerator. Then you divide, that's the divide button. Open parentheses, and then 2 times negative 4 parentheses squared after you close the parentheses on the negative 4 times y is 2 root 3. Close the parentheses on the root 3 minus 8 times y is 8 times 2 root 3. Close the parentheses on the root 3. Close the parentheses on the whole denominator. So that's what you type in. I understand why you wouldn't want to do this in math on your calculator, why you'd rather just use Mathway because it's more user-friendly. But again, you don't have that available to the test, so make sure you can use your calculator or do it in your head. You end up with root 3. By in your head, I mean like work it through. Once you got that, what does that tell you? The slope, and we want the equation of the tangent line. Put the slope with the point of tangency, and you got your tangent line equation. Done. Any follow-up comments on 37? 77. Are you able to talk now? All right. All right, pause. Any questions getting to there? He just went through like 5 lines of work in 8 words. Okay, we're all cool with dy dx being negative x over y. Nobody's going to object to that. If you're like, no, I don't really get it, but I won't say anything, that's your problem. All right, then what? All right. So now you know something about y, and then what do you do with it? So you square this thing, you get square the top, square the bottom, you get 16x squared over 9. 1x squared is like 9 over 9x squared. So you can combine these into a single fraction. And then you can solve for x squared and square root. Once you got your solutions for x, what do you now do? Yeah. You can plug them back into the original function, or you can plug them in here. Looks like you did this one. Find your one. So, and that gives you your y's. Ta-da! Good stuff. Any follow-up questions to 77? So, this is actually a lot like finding where the curve has a horizontal or a vertical tangent line, except in those cases, you got to know a little bit about horizontal and vertical lines and understand, oh, a horizontal line has a slope of 0, and a vertical line has a slope that's undefined. But it's the same idea. You're given a slope here explicitly. Hey, the slope is 3/4. Set the derivative equal to that. And then from there, it's almost like a K problem where you have to do this like substitution back and forth between your slope equation and your original equation. Okay. Any questions to 77? 31. Awesome. Oh. What rule is all that? All right, let's change it. Then over here, what rule did you use? Product rule. I don't know why we're like having the 4 out here. That's odd. Why not just do 4x squared dy dx and 8xy? That's just, it's like you're just copying off the key. It's something that the previous person did on the key for some reason. I don't know why she did that. I don't know. It's a dumb way to do it. All right. So just because the key did something doesn't mean it was a good way to do it. Anyway, you have that. Then, why didn't you just distribute the 2 to the x squared plus y squared? Why did you distribute the 2 over here? No, that's not why. Because from yesterday, is this exponent always going to be a 2? No. And if it were bigger than a 2, say 7, and we had 7 times something to the 6th, would you be able to distribute the 7 through this parentheses? No. So on the off chance that you might have another example, say on a quiz, where that exponent up there isn't 2, it's bigger, and so you still have an exponent on the x squared plus y squared, it's safer to get in the habit of multiplying this coefficient to dn, because that will always be allowed. And then, once you've got that, now it would be helpful if you like wrote all your stuff down, because you like skipped a step between here and here. You now have 2 times 2x is 4x, and you don't distribute that fully through this parentheses for the same reason. You just kind of say, all right, 4x times that parentheses, boom, and 4y dy dx times that parentheses. That's what this is. Just in case the parentheses here has a larger exponent that prevents you from distributing through it all the way. Yes, Arfa? Instead of distributing, yeah, you could also say, hey, I've got a common factor of 2 here. Just divide off the 2, and then I don't have to worry about that at all. And then you have smaller numbers. So I like that better method best of all, if that's what you did. Then what? So you distributed all this stuff out anyway? You're not wrong. But again, in the event that you actually have an exponent still in the x squared plus y squared, I'm going to recommend not do that. Also, by doing that, you're just making more work for yourself. So would you rather see a shorter way that doesn't involve more distribution than necessary? All right. Delete. Sorry, Mosley. Great work. All right. So instead of distributing this out, because again, you might not be able to, if the x squared plus y squared thing has an exponent, just treat this whole thing as its own term, because that's what it is. This is a big, ugly term. And this is its own big, ugly term. So we want to get all our dy dx things on the same side. So let's bring the 4x squared dy dx over to the left. So we'll have a 4y dy dx quantity x squared plus y squared that we're not going to distribute out, just in case in the future that thing has an exponent. We'll subtract over the 4x squared dy dx. Over here we have an 8xy chilling, and we'll subtract over this whole thing, 4x quantity x squared plus y squared. And since that was positive, when we move it over here, we have to subtract it, so it's minus. Any questions with that step? Then, on the left side, what does everybody have? That's really important. dy dx. Please, move the phone. And then pull out the dy dx. And it leaves behind a 4y attached to the x squared plus y squared. And it leaves behind a minus 4x squared. So when you pull out the dy dx from that left side, you've got that stuff left over and the 4x squared left over in parentheses. On the other side, do nothing, just let it be. And then you can finish this off by dividing this mess over here. You end up with dy dx equals 8xy minus 4x quantity x squared plus y squared, which might be raised to another power, over 4y quantity x squared plus y squared minus 4x squared. And what Mazen had wasn't wrong. What Mazen did was absolutely totally fine. You could have distributed out everything over here on the left side the way he did, but that's not always an option if you're starting off with like chain rule raised to some greater power than 2. Then plug 1 in for x and y and evaluate. I think you end up with 0, right? Because if you plug in 1, what's 8 times 1 times 1? Not even Ahmed needs math with that. So what's 8 times 1 times 1, Ahmed? 8, good job. Then 4 times 1 is 4, and 1 squared plus 1 squared is 2, and that's 8 minus 8 is 0. And on the bottom, well, we might, because what if it's also 0? So what's 1 plus 1? What's 4 times 1 times 2? What's 4 times 1 squared? Okay. So then the derivative would be undefined. So you get to do all that work just to find out the derivative doesn't really exist. Any further comments? Yes, Ahmed. Okay. So if I would have 2 or 3 squared, if I were to do that, Yep. So yeah, if you do 2 root 3 all squared like that, you're squaring both of these things, and there's no plus or minus, so you don't have to like distribute it out. This is like the whole thing just gets squared. 4 times 3 is 12. What? What's the math? Guys, watch out. Rows 3 and 5. 3, 5. Oh, somebody stapled their own work so I don't have to? You're my new favorite person. All right, whiteboards. You guys can see what stuff you need to know and be able to do on the quiz tomorrow. So know your trig derivatives. We'll review those right now. They're not going away. Awesome. My favorite person. Whoever's favorite person is, too bad. You're more close.
Okay, that's my flashcard.
You know, make your own platform.
I know, she's mine. Girl, I gave them back.
I take 5 minutes for you to wait.
Oh, but it takes. Yeah, so
Steve, can you catch like 4 things at once?
No, I really.
Okay. Hand those over here.
I definitely I just I gave them back. Wow.
You have a good point, but take enough from your own and pass the whole thing over, please. 5 and erasers are common. All right. So on the whiteboards, I want us to look at a problem similar. Ooh, I don't want to have that there. Look at a problem similar to 31, and then similar to, well, using trig also, and then we'll see what else we get through. So you got to know your trig derivatives. They're not going to show up all over the place, but they'll show up on like maybe 2 problems. You got to be able to just, here's a function or equation, what's the derivative, get dy dx by itself, and then that's all. So there's going to be 4 of those where all you have to do is get the derivative and stop. Then there will be a problem where we give you a curve and you have to find and then use the derivative to get the equation of the tangent line or the normal line at a point. You'll have a problem where we give you the function equation and say find the second derivative. So you have to get the first derivative and then differentiate that. And then you'll have a problem where we give you the curve and you say find the derivative and then use it to find the points on the curve where the tangent line is either vertical or horizontal. If you need more practice with this stuff at home on your own, you've got that worksheet that I gave you guys over the last couple of days, depending on when you were here. And the answer key to that is on Schoology at the top of the folder for the week. And then there's also all the problems in the textbook that I didn't assign to you. The ones that would maybe be relevant are those 50 problems. I don't recommend doing all 50 or even close to that, but if you have no life and you're bored and you're like at home and you're like, what could I do to make my time worthwhile so I don't have to scroll through TikTok? You have 50 more problems to choose from that you could do. The answers are in the back of the book on the for the odd problems on pages A43 and A44. So I'll leave 31 up there. Let's look at something similar to 31, but where we have a larger exponent, so that we really have to kind of do that like only halfway distribution. What banquet is it? So here you go, x plus y to the 7th plus x equals y. So what made 31 especially bad is that you have chain rule as well as product rule going on with the same problem. This, you just got the chain rule to deal with. Everything else is relatively normal.
So this is where you then kind of halfway distribute. So this multiplies that. And then this. So 7 times x plus y, but 7 plus y. Do the same thing, the same body x. All right. Hamza needs a new marker. All right. So times d in times d out. And then plus 1 equals d body x. So just make sure when you're doing chain rule, the inside times over the outside. So times. Then you multiply that over here, which is good, times, and then we're doing like halfway distribution. 7 multiplies to that whole thing, and you have 7 times the thing. And the 7 d y dx multiplies that thing, and you have 7 d y dx times the thing. So you don't like really distribute through the parentheses, you only kind of halfway distribute and say the 7 multiplies that whole thing, but the exponent blocks you from distributing. That makes sense? And then plus 1 equals d y dx. And now you can move terms across the equal sign, maybe pick this whole thing up because you got the d y dx, bring it over here, and then you can factor and isolate d y dx.
I'm going to start this stuff up. So, chain rule. What's the derivative of the inside part? Good. That multiplies the derivative of the outside part. What's the out? Beautiful. Then, derivative of x is, and derivative of y is, if you do that, you're already getting partial credit. You will not get a 0 if you do that. Then, because you've shown me I know how to do my implicit differentiation. That's the only calculus step. Everything else is nasty algebra. At this point, the 7 can be distributed to which piece? The thing on the left. It can't be distributed to the x plus y because it's the exponent. So I would distribute the 7 through the 1 plus dy dx factor. That whole thing is still multiplying the x plus y to the 6th, and plus 1 equals dy dx is just chalk. Questions with that? This next step is the other difficult step. I feel like the first step is difficult, distributing the 7 isn't so bad, and then this next step is difficult with like, we're only halfway distributing this out now. We're going to distribute the 7 and the 7 dy dx for this stuff, but not through. So we're going to see 7 times this, but we're not going to put the 7 through the parentheses. So we'll just sit the 7 in front of the x plus y and say 7 times is the x plus y. That's 6. And we do the same thing with the 7 dy dx. The 7 dy dx also multiplies the x plus y to the 6th. We can't distribute it through the parentheses because of the exponent. So that exponent kind of blocks a full distribution. But you can at least say, well, the 7 is multiplying that, and so is the 7 dy dx multiplying that separately. And that allows you to kind of separate these two items from each other into two fully separate terms. Plus 1 equals dy dx is 2. And at this point, it's now you have like everything is separate terms. Get the terms involving dy dx together, get the terms that don't have dy dx together, and then factor out the dy dx and isolate. So this entire term here can be brought over to the right. Just pick the whole thing up. It becomes minus 7 dy dx. That's y to the 6th. This stuff is just sitting there minding his own business. And then everybody on the right now has what? A dy dx. When you pull that out, what's left from the first term? 1, don't forget that. What's left from the second term? 7 quantity x plus y to the 6th. And then divide that parentheses stuff over, and you got your answer. 7 quantity x plus y to the 6th plus 1 over that mess. 1 minus 7 quantity x plus y to the 6th. In my mind, that's the toughest thing on tomorrow's quiz is in terms of like messy differentiation. And you'll have exactly one up to that level of nastiness. And unlike 31 on the homework, you won't also have like product rule elsewhere in the problem. It'll just be like, okay, this problem's ugly thing is chain rule. Go. I'm not going to throw chain rule and product rule to that level in the same problem. Any comments or questions before we move on and look at another example? How do you guys do? Now, what if you like screw up at the beginning, but then like it's kind of hard to check your work against mine after that. But if you like follow through a bad step at the beginning correctly, I'll give you most of the points. I'll take off points at the beginning for bad differentiation, but then I'll enter into your alternate universe and I'll see in your world, did you do things correctly with your algebra afterwards? And if you did, then I'll give you at least half credit. Same thing as if you start off well and then fall off the wagon, I'll give you steps for starting off well because you did your calculus stuff right. You just got lost in the weeds with the algebra. Trig, what's the derivative of sine of x? What's the derivative of cosine of x? What's the derivative of tangent of x? What's the derivative of tangent of x? What's the derivative of secant x? And what's the derivative of cosecant of x? Yep. So take secant, make it negative, and turn those things into the cofunction. So you'll have like 2 or 3 equations tomorrow where there's a trig function like in with everything else. Let's look at a couple of those. So say you have cosine of 3x. I want to get 3y. Cosine of 3y plus x minus 7. Go, get dy dx for me. Yes. Real close. So you got to do the chain rule on the side. So we're just cosine of x, cosine of y. Great. But it's cosine of 3y. Yeah. So differentiate that, and then we get negative sine of 3y. So the inside of the trig function will always be 3y, even when you change the trig function. That's good. Yep. Times 3y. Because it's not 3 plus y, it's 3 times y. Yes, the negatives can cancel out on the 1 and the 3, but you're not wrong. This is good. And all this stuff divides. Because all this stuff is so it's that stuff to get 3 and 3 on 3 so all that stuff just divides. There's no like plus or minusing separating the body and any of that stuff.
Oh, I need to.
So I can divide the negative size of each 3 sides. Oh. So, looking through here, let's go with chain. This is chain rule because we have stuff inside cosine that's not just straight up x. Even if it were y in there, you'd still need chain rule because the derivative of the inside then is dy dx. So, what's the derivative of the inside part? 3 dy dx. What's the derivative of cosine? Negative sine of 3y. What's the derivative of x? 1. What's the derivative of 7? 0. It's dead. Equals 0. So that's your step 1. You might have these things arranged somewhat differently in terms of like the order. Just make sure a couple things. First of all, the only thing inside your sine function is 3y. Don't sneak an x in there. Second, the 3 and the dy dx are outside the sine function and multiplying. Third, everything here is getting multiplied. Fourth, everything here is getting multiplied. So it's really easy to like turn this times a negative into a minus. Don't. It's really easy to like think, oh, okay, I'm not going to subtract or add the sine function over. Don't, because it's getting multiplied with dy dx. So all the stuff is one big term. To isolate the dy dx, you'll have to divide off the negative 3 sine of y. So what I would do now is subtract over the 1, because that's a separate term. Maybe rearrange these terms so they have negative 3 sine of 3y times dy dx. And that makes it a little more clear what's going on. And then divide that whole thing over. Get 1 over 3 sine of 3y. And that's dy dx. Questions with that? Adam? Oh, this is like, if say the x wasn't there. Then we'd have that stuff equals 0. And what's 0 divided by anything? So then dy dx would equal 0. That's boring. All right. Say you have tangent of y, and then watch out for some product rule here, minus x squared, y equals 7. How does also have to be? I got it. Yes, Miles. Okay, yes, true. When we have 0 over some big complicated expression, we can probably use it.
Yes. It's not square root of x is y. And y I apologize. That's perfect. Great. Yeah, that's good. Yeah. Good. Yes. So that's cool. And we have two numbers we want to get. So on this one, derivative of the first is 2x times the original second. If differentiate the y by 0, so that just leaves y. But this one, we are differentiating the second part. Because the original first times the derivative of the second.
Okay.
So either there is y and that doesn't. So this should just be y, and then you can bring that whole term over. And everything else you have is fine. So you just make that one detail, also that's y, add it over, and then take out the y, the x, the leftover stuff. When you differentiate the tangent of y, because there's a y in there, that's going to be a secant squared y with a dy dx attached to the outside.
I had an X written.
Okay, so if you have tangent of x, then what you have is fine. And you just can't read this problem. So you did your problem correctly. You didn't do my problem. Good. Good. Let's go over this. So when you have tangent of y, the derivative of tangent is secant squared. The thing inside there is a y, and then sneaky chain rule. What's the derivative of the inside part? Dy dx. You got to multiply that on the outside of your secant function. I like to put outside things in front of the trig function. Over here you have product rule. This is sneaky product rule because you're subtracting this term. So when you do your product rule, you're going to minus both parts of it then. So derivative of the first part is 2x times the original second is y, plus the original first part is x squared times the derivative of the second is dy dx. But you're subtracting this whole thing, so you subtract the entire product rule, and that's really a minus on both. So be really careful with that. It's really easy to forget that minus and let whatever thing comes second be a plus. That's 0 then. And then you take the 2xy over here. With the remaining terms, you take out a dy dx, and that leaves behind a secant squared y and a minus x squared. And then you can divide that over, and you're done. So you guys are pretty well with that. We got time for when we get out of here. 41. One more. So let's say you have 3y squared equals 4x over x plus 7. So what's the difficult thing with this one? Question. I think there was one problem on the homework last night that was in the same similar vein.
I don't think so. Yeah, you can reduce the fraction, but that's great. Multiply. So when you divide the 6y over, it multiplies the denominator, doesn't add to the denominator. So it'll be 6y times that x plus 7 stuff. You need to do, so I think you forgot low. So this is great, make it a low over, attach that to 3y down there. Don't lose your y. So it's not 6 u by x, it's 6y u by x.
So that would be.
So that's, you could reduce the 28 over 6, but what you have is great. That's awesome. That's great. So when you divide 6y over, you get like it's just ta-da! That's good, Jada. All right, so going over this, 3y squared becomes 6y dy dx. Over here, you're doing your quotient rule. When you've done your quotient rule, you should be getting 28 over x plus 7 squared. Does anybody have any questions with the doing of the quotient rule part? All right, then, once you're there to isolate dy dx, you divide the 6y over. Where can you put the 6y so you don't just have like a fraction over 6y? Just put it in the denominator. So when you divide that over, the 6y just sneaks into the denominator in front of the x plus 7 squared. A couple people in your quotient rule forgot about low. So you did everything great in quotient rule, you divided the 6y over, you just forgot about like x plus 7 squared. This can be reduced. 28 over 6 is 14/3, so you could like go another half step and reduce the fraction. But that's great. So between the last 2 days of like doing these application problems with like equations of normal line and tangent line and finding places where the tangent line is horizontal and vertical, and then between going over some of these practice problems today, just hey, can you get the derivative, get the derivative, get the derivative? Hopefully you're in good shape. You got recordings for the last like 3 days on Schoology. So if you missed a day or two, you can go back and check those out. And let's find out for choice, please.